All right. Should be sharing. You should be all be able to see my screen now. All right. So yes, I'm Ioannis Petros, although I mostly use Petros actually. Yes, today I'm happy to present to you our work on human annotation and how it can assist music transcription systems. It's been a big part of my PhD in TU Delft, and also it's been my main focus on my work on Trompa, European project, which recently successfully concluded on June. Now, while working on Trompa, I was able to come in contact with professionals in the domain, and I was able to assess the quality requirements that professional institutions need from their digital music scores, and found out that big orchestras or music libraries mainly use experts to actually transcribe their music scores. And this can be quite an expensive procedure, ranging up to thousands of euros per music score, which can be quite prohibitive for smaller orchestras or for semi-professionals, let's say. Now, of course, there are automated methods that we discuss also in this community, but the outputs can vary quite a lot depending on the music score that you have as to transcribe. So in times, maybe the user needs to heavily edit the result of the output of that system. For this, now in general, having one music score to transcribe can be still manageable by either just finding the budget to hire someone, or finding the time and the people to share the editing later on. But we hit a big problems on scalability when we try to transcribe big sets of music scores, where cost and time start increasing to quite prohibitive amounts. So for that reason, we looked into crowdsourcing in our research to help with scalability and efficiency, since it has been successfully integrated to other projects for image recognition or for text manipulation, etc. Now, in the case of music transcription, we actually divide in a pipeline. We will roughly divide the processes into three big categories of image pre-processing, where we have the segmentation of music score or color correction, etc. And then we have the music notation recognition and segmentation, to identify, let's say, the clefs, typing signatures, etc. And then, of course, we have the semantic reconstruction of the music score itself. Now, these are very big tasks to just give to humans as is. For the reasons also we described earlier. So what we really want to do is break down these processes of music transcription into small, small meaningful tasks that we can always publish to users, and we can algorithmically integrate into our transcription pipelines. For that reason, we looked into microtask crowdsourcing, where through its design, we can have very specific inputs and outputs per task. And we have very specific small tasks that a user can quickly execute. So we can always integrate the result from and the annotations of the users back to our transcription system. So in these cases, the crowdsourcing can be used in either data creation, data cleanup, or to help training our machine learning algorithms or fixing its output. Now, a few things that we need to bear in mind while designing tasks for music transcription is the varying music knowledge of the user base, because we can either find people who had actually some experience in music theory, or just people who never saw a music score before. So for that reason, we need to design the tasks in a way that actually decreases the cognitive loads and decreases also the chance that the user will drop the task. Also, this will help in general by these design elements. We can actually increase also the performance, try to increase the performance of users by assisting the user experience with interface elements, or trying to make the explanation of the tasks as accessible as possible to the users. Now, in order, and now the literature for crowdsourcing music transcription is quite scarce. And for that reason, we wanted to really explore elements of task design that can affect the performance of crowd workers. So we devised an experiment where we varied the length of the segments to be processed from 1 to 2 to 3 measures. And we were interested in detecting errors on the transcribed piece of the music score. So for that reason, we varied also the user interface to have image-to-image comparison, which is a quite classic example of finding errors. But also we had audio-to-audio comparison, because we want to see if the acoustic element of music would actually assist furthermore the detecting errors on the transcription. Of course, in the end, we want also to see if the combination of the two yield better results, so we included that as well. Yeah, since the time, I will actually try. Yeah, so errors also, that's we try to vary the errors, the type of errors on the transcription. So we actually use correctly transcribed music score, and we injected basically the errors ourselves with either missing notes, wrong pitch, or wrong duration. And we published our task on Mechanical Turk for 144 workers, where each worker executed 9 microtasks. And we also include some questions about the musical sophistication, demographics, and cognitive load, because again, the literature was quite scarce, and we were really interested to see also some other aspects of the crowd itself. So in the end, we found that the best segment size, to our surprise actually, was the 3 measures. And apparently both image and audio, the combination of the two really assisted greatly the users to identify errors in the digitally transcribed score. Now, when we aggregated, we used a simple majority votes algorithm. We actually found that the aggregated performance of the workers was quite high, And to a degree that we can assess that crowdsourcing could be viable for error detection in music transcriptions. Now, how this fits to the whole hybrid annotation model? This type of tasks could be used in the pipeline where we try to fix or identify the errors of a machine learning algorithm. And the feedback from the crowd can actually either, okay, this is, with this actually I'm ending also the presentation. It's mainly what's,
You can go ahead for 1 minute, no problem. So it's just
okay, for 1 minute. All right, so maybe I will go to some more Trompa related, maybe. So through Trompa, through the 3 years of collaborating also with partners, we were able to create the first prototype of such hybrid annotation system, where we had a PDF as an input of a score, and we used algorithms to segment the score and create tasks, create a pipeline and tasks per music notation that we want to recognize by the crowd. And this prototype was evaluated and used with semi-experts, where members of youth orchestras annotated parts of the score. And yeah, so far it seems to be quite promising, as the results seem to be quite promising to combine both techniques. Yeah, I don't know how, I don't want to stress too much my time here. So I think maybe it's better time for questions, maybe, I don't know.
Yeah, okay. I think we are, okay. You can close this. Thank you very much.
You're welcome.
For people at home, you can use this reaction button and say applause. Okay. And I'm going to try, okay. Well, it says Alexander Paja because I'm using his computer, but it's still Jorge. Okay, thank you, Petros. And I'm sorry, I was calling you Ioannis.
No problem. Yeah, it's yeah, two names, both first names. So it's, yeah.
Well, thank you, Petros. Anyway, so I think we have time for a couple of questions, quick questions. If there is someone in the audience that can.
Definitely.
Wants to add something.
Maybe I should stop sharing.
Okay, you can use this reaction button to raise your hand, or you can just chat your question if you have one, or yeah, just speak up. I mean, there's only a few of us, but well, anyway, I'm going to follow. I think it's better raise your hands because then I can give you word by order. The first one is Ichiro.
Hi, Petros.
Hello.
Thank you for talk. When you're using both the visual and the audio, what happened with the time? You didn't mention time. I usually find it takes time to listen. So did you record the time, or just how many measures they were able to do per minute or per hour?
Yes, thank you for your question. So actually, the time needed was only a few seconds per example, since we only use either one measure or 2 or 3 measures. So the examples were quite short. But of course, by using audio, we actually indeed increase the time needed for the task itself. Yeah, that is a given, that increase the time, because but we wanted to assist as much as possible, and we want to test the audio also to see if it could actually help or not, and it proved quite helpful actually in the end.
Okay, thank you.
Thank you.
Okay, next, David, you raise your hand. Go ahead.
I don't. Thank you for your talk. Well, I had a question about the crowdsourcing. I've seen that you first segment the work into measures.
Yes.
When you're distributing the tasks, I suppose that they are distributed not by measures, but the whole stuff. Is that correct or?
So in this specific example, we wanted to really compare the different elements. So the 9 microtasks that each worker had to execute was basically to fill up the matrix of the different variables. So each microtask was either one measure or 2 or 3 measures. So it wasn't the whole stuff. Yeah.
Yeah. So when you have, for example, a slur that processes several measures, you keep them together, no? When you distribute it.
Yes. So when we introduced the mistakes, because we wanted to actually control also the errors, we made sure that when we have longer than one measure, to actually introduce, we were randomly introducing errors on the whole segment, basically.
Okay, it was my doubt. Thank you very much.
Yeah, you're welcome.